Introduction to computers. This is Tuesday, Thursday, and we did spreadsheet work, which won't be in the recording, but almost all that stuff would be in podcast eventually if you want to look for it. And it's week 6, Thursday. All right, 3 major things we talk about: system software and applications. I'll go through a few specifics, and then we talked about types of computers or computing devices. So there really isn't that much to go over. And key things, first of all, operating systems. The functions, they manage hardware resources, they manage the hardware, they take care of things like what information is in RAM, what needs to be moved up to the processor. They manage all of that multitasking when the computer appears to be doing multiple things at once. They keep track of all of that. A good example of also managing hardware would be if you save something out to a hard drive. The operating system manages how to put it out there, where it's at. When you need to get it off, it brings it back in. Your application doesn't have to worry about that. Operating systems have all different kind of features. Probably the most obvious one would be the GUI. If you look at different operating systems, they have slightly different GUIs or extremely different GUIs. The GUI is the graphical user interface. It's the way that us humans communicate with the system. A way to open up apps, a way to close apps, how we look at it in order to store things that we're working on, access things through the internet, everything. It's that view. So that would be one of the key features. There's other features that are unique to certain operating systems. Categories, we have operating systems that run on different devices that we have. So for example, smartphones, 2 major types of operating systems for the smartphone, whether you're going with an Apple product or a non-Apple product. Same thing with the tablets, netbooks, laptops, and so forth. We have operating systems that will run on servers, desktops, and another whole different category of operating systems that run on mini computers, mainframes, and supercomputers. Okay? Another type of category might be the operating system that functions in your microwave or at some large manufacturing plant. In your automobile, there's an operating system in your automobile that's specific to that type of equipment. Okay? We have utilities. We have software that helps us manage files. We have the task manager, Control-Alt-Delete. You open the task manager, you can see what processes are running on your computer, how busy the processor is, how much memory you have left, and so forth. And then we have a whole set of utilities that allows update user information. You can design your computer so people can log in and out, or for anybody logging in and out, or nobody has to have a login. You can just use it. You can manage what hard drive space is used for who and so forth on a computer or a computing device. Device drivers. When we have devices on our computers like a printer, there is a piece of software that is loaded on the computer that allows the device to talk to the operating system. So when the operating system knows when an application wants to print, it sends a request to the operating system actually does the printing. And it knows how to talk to the device, whatever kind of printer you have, through a device driver. Operating systems come with all kinds of device drivers built in, or in some cases when you get a new device you might have to actually load the device driver either off the internet or off a DVD. Applications. We have this whole group of applications called productivity software, word processing, spreadsheet, database, presentation, graphics, and so forth. Those can be done collaboratively. More or less we can use a location out on the internet to use that information. Like you can use Google Docs for those, all of those, or products like Microsoft is creating cloud capabilities for using their productivity software. There's Open Office, and there's different places out there where you can use cloud facilities to manage your documents collaboratively. Okay. Custom apps, you can have somebody design specific apps to do a specific thing. This can be expensive, but in some cases there are no specific packages to do what you want to have done, or it might create a competitive advantage for your company to have a custom app designed to do something specific. Like Walmart has its software that manages its information system. Facebook, certain software is written to make that work as it does. You don't buy that off a shelf. Facebook, they design it and use it. Amazon, how they manage things and so forth. You can buy specific packages to do something, like TurboTax to do your taxes, Quicken to do your books and so forth. And then there's the whole world of gaming, game software. Believe it or not, you can buy software that helps you create software. For example, all those apps that go on smartphones and tablets, you can buy software, or you can get some cases, some of it free. It's referred to as development software that allows you to create software. Related to hardware, the software makes the hardware work. Okay? Typically, you need to find what you want to do with a computing device. Then you find the apps that allows you to do what you want to do. And then those applications will run on a particular operating system and give you specifications into what kind of hardware you might need. So a simple example would be if you were going to buy Photoshop, Photoshop would tell you you need a certain amount of hard disk space for the software, you need a certain amount of RAM for the software to run efficiently, and you need a certain level of processor to run that software on your computer. So if you know you're going to use a package like Photoshop, okay, to do graphic work, that'd be like a specific package, you better have the hardware to do that. Okay? So the software drives what you need for hardware. We talked about mobile devices, smartphones, tablets, netbooks. I put a question mark there. Netbooks. They're like laptops. They have keyboards. They have small amount of memory. Usually not a real fast processor. They're designed cheaply for people who just want to connect to the internet. I'm not sure that caught on. People tend now to either get a decent laptop, or they'll go with a tablet, or they'll just use their smartphone. Again, these devices, when you buy them, battery life, what apps you absolutely want, need, and so forth, leads towards what type of device you need. Desktops are computers you can buy that would be not mobile. They're usually in a box. If you're going to buy a laptop and a desktop with the same capabilities, what capabilities are important? Well, if they have the same amount of RAM, basically the same processor, they're both 64-bit, and they had the same clock speed and so forth, you could buy a desktop way cheaper than you buy a laptop. Because to put those features into the laptop and make it convenient to move around and so forth costs a lot more money than if they put in a desktop. So you just have to see what serves your needs. Servers are high-end desktops used for people to access. And then we have all these mini computers, mainframe, and supercomputers. These are all a step up from these. You know, mini computers can be used in medium to large size companies to do their computing needs, maybe manage their manufacturing and so forth. Mainframes are in big companies. They could cost from $1 million plus and used, for example, there's a mainframe made in Clear Lake at Unisys years ago that actually runs Disney World in Florida. Okay? Supercomputers are extremely expensive, high-powered computers that do things like weather forecasting, simulating complex issues, and things that require a huge amount of computing. Not a lot of supercomputers in the whole world, actually. All right. That is almost it for Unit 3. We've got Unit 4 to cover and finish up spreadsheets before midterm. And